It is Tuesday, December 24th, 2019, otherwise known as Christmas Eve, and welcome to this episode of Code Evolution. So I wanted to do a walkthrough and a demonstration for people who aren't familiar with channels to kind of get a lot better exposure to something that is extremely useful when it comes to pipelining and doing asynchronous programming, and that's a lot of what happens these days. So in your career, as you progress, you're probably going to get to a point where you're starting to do more and more async type of operations, and you might actually hit a point where you're doing some pipelining of data. So to do this, we're going to just do a full walkthrough from scratch to kind of demonstrate the pattern that's required for channels. Now, we could also kind of talk a little bit about data flow, which is kind of something very similar in a lot of ways, where it's a very easy way to set up a pipeline. But what we're going to do instead is I'm going to actually show you, after kind of reviewing the pattern, how easy it is to actually do basic, data flow style operations, as long as you're not trying to do anything fancy, like too fancy that only say data flow can do, which is pretty powerful. But we're going to do it with channels. And we're going to use channel extensions to demonstrate that. So first off, we're just going to start off by creating a new console project, right? So we're going to .NET console, okay, and get it all set up. And here we go, right? Just real basic stuff. All right, and then what we're going to do here is using System.Threading.Channels, okay, to get started. Yes, I would like to add them. Yes, please. And, obviously right out of the gate, we'll, let's see here, I'm going to do open the console and just say .NET run, run, all right. Yeah, everything's good, okay. All right, so channels. All right, a channel is something, it's basically an asynchronous producer-consumer queue that was developed originally in the .NET Core FX lab, and actually even previously to that, I believe it was actually pioneered by Google. So a channel is a great way to manage this because its API is very straightforward. So if you want to create a channel, let's say if you want to have something that essentially is an asynchronous buffer, right? We're going to say var channel equals channel dot, and we'll start by creating an unbounded channel. And then you need to set the type. So in this case, we're going to say, let's use numbers, okay, or integers. So now we have this channel that is of type int, right? Now a channel has a reader and a writer. So in this case, if we want to write to the channel, which we're going to do, so let's say we're going to go, let's say we want to write 1,000,000 numbers to the channel, up to a point. So let's say we'll start by saying a constant max, constant int max equals 1,000,000, okay? Just to kind of predefine that. Then we're going to create a for loop. Okay, and then we're going to say channel dot, and the writer, okay? And in this case, the options that we're provided, okay, are try write and write async. All right, well, first of all, we're going to want to make this an async start, okay? And then the thing you have to consider is that when you're writing, why do you have a try write? Let's talk about that. So if you could easily do try write, and we'll say I, and that is a synchronous method that returns a Boolean, okay? And for the most part, if we run this, it's going to work just fine, and there isn't going to be, any issues with that. But let's continue the pattern for a second, and let's talk about reading, right? So what we would expect to have happen after this is that we should be able to count the number of entries, and they add up to 1,000,000 if this was to work correctly, right? So after it's written, and doing this in a very synchronous fashion, we're actually going to while channel dot reader dot try read out var I, okay, and then what we're going to do here is we're going to create a var count equals 0. All right, real simple stuff. Count. All right, so let's format everything. And then we should be able to say with some level of confidence that after everything is said and done, we could say that console, console dot write line, and the line is going to be, we're going to say total count. Okay, and so we should actually get, this should work per se, okay? And we're going to go ahead and try it out here. So as is, we would expect this producer consumer queue to show us the number 1 million. Okay, what happened here? Well, we need to import tasks into the thing. So we're going to, I'm going to close the terminal here. And let's see what we got happening. It wants to, yep, there we go. And then it should compile just fine. What is it giving us any grief here? Okay, well, we're not awaiting anything yet, but that's fine. Let's go ahead and see if we can get this thing to run. Okay, what? Let's see here. Task, the type of namespace task is, maybe I needed to save it or something here. What's going on? There we go. Okay. So yeah, the total came out to 1 million, which is exactly what we'd expect from this queue, right? It basically, this PC queue, we added 1 million items to it, and we took 1 million items out, and we got what we wanted, right? For the most part, all good, right? It seems fine. It seems kind of like just basically we could exchange this whole thing with, say, like a queue or any other collection, and that would appear to work just fine. But here's where it starts to get a little bit interesting. Now, again, we've done this in such a synchronous fashion that we stopped after adding stuff in, and then we, also then continued only after there was, a full number, and then it exhausted it by taking the try read. Notice that the try read bailed out when there were nothing left in the reader, when it was empty. And that's kind of the whole point behind these try operations. Now, this try write, because it's a try write, again, it's a synchronous method that will essentially bail out of what's going on as soon as it can no longer write to the channel. But what we have here is an unbounded channel. So it basically is never going to, try write is never going to return false, or at least it shouldn't. So let's do a little bit of an experiment. So let's say, what if I do create bounded, okay, and I pass it a number, and let's say 1000. What's going to happen now? Well, to spoil, the operation, what's going to happen is it's going to write to 1000 and hit the maximum, which is 1000, and it's going to then continue to try to write to 1000 and keep failing. So what we're going to do is, to demonstrate a little bit better, we're going to say if, if we say if it's not able to write, we're going to break, so we don't waste any time. Because we're assuming that if we can no longer write to the channel, that means the channel is full. All right? And again, we're going to go ahead and run. And look what we got. We got 1000. We got 1000 because the maximum number that the channel could hold is 1000. But okay, so now what do we do, right? How do we make this work that it's going to continue to read everything from the channel, and that that it's going to be a pipeline that has a bounded amount? Because that's what you want, right? You want to hit a maximum, so you're not holding a lot of things in memory, and then you want to continue after the fact. So to simplify, and again, this is getting more and more complicated because I actually want you to see how complex this pattern can get, and then I'll show you how to make it simple. So let's go with, all right, so let's say to make this more effective, we're going to take our channel and we're going to set up the read operation first. So we're going to say, just for example, task.run, and we're going to do a setup here that it is going to be reading. Okay. And then again, what it's going to do is, and then we'll say var reading. Okay. And then we can go down here and we can await reading. Fair enough, right? So when reading is complete, then we can check the count. And so then what we're going to do here is we're going to come in here and we're going to leave the count as a value. Okay. And we're going to put this loop in here. All right. And so now we're setting up the read flow early on. So it's already ready to read. We don't know when the channel is going to receive data. That's the point, is that it could happen at some other time. So with that same thing in mind, we're going to say var writing equals task run. So we'll set up a whole nother situation where we're doing this completely asynchronously outside of what we would expect. Okay, and now we have these two things happening. So now what's going to happen here? Well, what's going to happen is, well, first of all, it has to complete this before it actually is going to complete. But what is going to potentially happen is this is going to fire off, and this is going to fire off after this. But this is already, like, when this starts running, there's not going to be anything in the channel, and it's going to return false and immediately exit. This await will complete, and our total could literally be 0. In fact, just for fun, let's go ahead and see what happens. It's very possible it'll just be 0. And there we go. So what happened here? Well, in reality, it did try to write to the channel up to 1,000 at some point. And in fact, if we wanted to be a little bit more appropriate, we could say await writing, await reading. That doesn't mean that it's not going to be total of 0, because what happens is the order of events, essentially a race condition, is going to end up being that it totals 0, because this one's going to run first. So how do we fix this problem? Well, with a channel, okay, we can now say, well, okay, I need to wait for new results. I'm not really done yet, right? This hasn't been finished. This isn't finished writing, right? So the first step you want to do is, after the writing is complete, we want to call complete. All right? So complete is going to signal to the channel that, hey, I got nothing more coming. I'm done. I'm not going to add any more to the list. So if you get to the end of your rope, there's no more rope, right? And so then how do we process through that? Again, what's going to happen here, if we run it, you're going to see again, it's going to probably still be 0. Okay. What we need to do now is we need to tell this while loop to smartly try again when results are available. So the trick behind that, and I think generally the correct pattern, is to use a do around the while. Okay, so we'll take this here, and I'll explain in just a second. And then you do while, and then again we're going to need to do an async await here. So we're going to go async to make the lambda an async method. All right, and then we're going to put in this while loop. We're going to say channel dot reader wait to read async. All right. Okay, and then we're going to say await. So what happens here is, while this is reading, so the first thing that's going to happen is it's going to come in and say, hey, I'm started. Hey, do you got anything for me? And it says, no, I don't have anything. Okay, I'm out. And then it hits the while loop and says, hey, do you have anything for me? And it says no, or actually just waits until there is something, then provides it. If the channel at some point here was closed or completed, then this is going to return false. So we're setting up the read loop and the writing loop separately, but this is the general pattern that works. And as you see here, we're going to see probably 1,000,000. Oh, we'll see 1,000. Okay, why did we do that? All right, let's figure that out. So again, the intention though is that the channel will continue to write until it's done. But here's where this is why we're only getting 1,000, because we reach our limit, and then we have to try again. So what we're going to do is when this reaches a max limit, we're actually going to tell it we're going to say while. Okay, that's false. Then we're going to say await channel dot writer dot wait to write async. Okay, that's one option for us to do here. Let's see. Oh, okay, we have to say, sorry, I'm going to say async. And there's an even easier way to do this as well. You could say, we could do the channel writer write async. So write async is always going to wait there until it can, and then we're going to go back to where we said, hey, we're going to say no await, and then we'll just say break. So it's at the end of the rope. Now keep in mind that this should never happen because we're in control of the writer. What's going on here? Sorry, let's do this to properly. Oh, excuse me. This is going to, right, this is actually the whole point about this, is we should expect this to, write async is not a Boolean. It's going to throw if the channel gets closed. But since we're in control of the channel, we should never be concerned about this. So we're going to simplify this down to, sorry, let me just keep that way, to this style. And so now if we run it, all right, we had 1 million now, right? So why? What just happened here? Well, the first thing that's going on, remember, these could fire in any order. Typically speaking, this one is going to fire before this one, okay? And we're gonna it's gonna wait to read, but there's not going to be anything in the channel, and then it's going to yield to the next task, which is now going to say, cool, I want to fill up the channel, and then the channel is going to get, because this is a near synchronous operation, these value tasks actually can continue synchronously, and typically they will. So you could expect the default behavior of this channel is to fill up to 1000, and then it'll pause because it's still waiting for room in this bounded channel, right? And then while this yields back, because there's nothing, it doesn't have any room to wait, this is going to start to read off the channel, taking maybe up to 1000 off, and then allowing it to kind of flip-flop back and forth. That doesn't mean that in these situations that it's going to behave in this kind of pulsing style of operation, but it also doesn't mean that that's bad either, because the way that the channel is built is to be very synchronously performant and friendly, to basically take advantage of the calling thread as much as possible. And there are some configuration settings that we can get into, but we're not going to do that for this purpose. But here's the general pattern that you should be comfortable seeing, and that's that a channel, first of all, you have to wait for the results. And actually, to be correct, see how I said I'm saying waiting to read? And this is okay too, because this is basically saying it's signaling outward that, hey, once I'm done, go ahead and complete. But maybe a better thing to just be 100% certain about. I mean, we know for a fact that this is true, but the important thing to make a note of is we also, in most cases, should be awaiting the channel.reader.completion task. And this is so that when you expose a channel reader, you don't have to think about the inner workings, and something else can kind of wait around for this task to complete. And so you could do that here. You could do that here. It doesn't really matter. And in fact, another way to consider this is we could say, let's do this, and we're going to get rid of our variable because we don't need it. It's just we're going to run this. Let's see here. We're going to say, let's get rid of this. This warning here. All right, cool. And run it again, and we should get the same results. We're at 1 million, right? Because that completion task is the same thing as saying, hey, I got no more left in the channel. The channel is empty. The channel has been closed, and there's nothing left in it, right? So, okay, now that's cool, but that is, that's somewhat a lot of, that's not a trivial amount of code that we just wrote, but that is the general pattern that you should be aware of in how channels work. Or to be correct, essentially producer-consumer queues, and more specifically asynchronous producer-consumer queues, are going to have this completion task that you're waiting on. If you are in the case of, if you're using .NET Core 3, which this is a 3.1 app here, there is another way to do this as well. And so I'll review that with you. So we're going to say we're going to say await for each var I in, and here we go, channel reader.read all async is the method. and that is an iAsync enumerable. This is just so far is not part of .NET .NET Standard 2.1 yet, as far as I know, but it is part of the .NET Core 3 Plus standard. So we could even go as far as, yeah, that's it, right? We reduced the code down a lot. It's just, oh, sorry, we need to add the count. Still needs to stay in here. So what we'll do is we'll take this and replace this, and we'll take this out and do this. So we want to keep the count in there, right? And then we'll say do the format. All right, there we go. Now if we run it, cool, same thing, right? But Async Streams is available in .NET Core 3 with channels, and it definitely makes it for a lot simpler code, right? Like you get rid of all that. So that's a big deal. So you kind of make it definitely makes it much easier to progress. And in fact, for example, we could go as far as, simplifying this down. I know that we're writing to the channel, but here's something to consider. Because it's a bounded channel, and we were to go in here, we can say, in reality, we can actually even take all this out. This is how much more simpler things can get with Async Streams, and that is we're setting up this writing code. But remember that this for each is actually designed not to exit until there's nothing left. That completion event has to be triggered before it's going to complete. So this has to reach this point before this actually completes. So again, we'll run this and you'll see. Right. So again, much cleaner. We know that this task is set up to run. Initially, it is a bounded channel, so it will stop at 1000. This is going to hit this for each, and there's nothing going to be in the channel reader, so it's going to wait here, allowing the task to yield to this code, and then this code is going to run and keep adding stuff to the channel until it's completed, until there's nothing left. There's no more than a million. There's up to a million in it, and then this will eventually complete. It'll get the complete signal, and it will consider that this is done and exit out. So again, here's an even simpler, more straightforward pattern that works really, really good for using channels at this stage in its development. So now let's get into even the kind of a further kind of simplification, at least depending on how you code. There's, you might have something even more straightforward that you want to do. So this is, occurs if we install, let's see here, if I think I get this right, we're going to go .NET add package, I think it is, and we're going to do open.channel extensions. Okay, great. And then we'll close this up, and then we'll say using open.channel extensions. So the first thing I want to demonstrate is just a different way of doing things. So channels can be essentially, we're talking about pipelines, right? So if we want to pipeline something through a process, we kind of don't want to have lengthy code like this. We want really simple code, and we want it to be, easy to read. So we're going to start off by, let's say we have this channel. We also are going to have a source, which is going to say enumerable dot, and I think we need to import the link namespace here. Yep. Dot range, and I'm going to say 0 to max. Okay. So now we have this enumerable that's our source. And then what we're going to do, we're going to kill all this off. Okay. And we're going to say that, let's see, we're going to go ahead and, we don't need the count because we're going to explain that in a second here. We're going to take our channel, and we're going to say that the source, this is using the extensions, is the source. Okay. And now we have a starting point for our pipeline. All right. And now, simply put, we can say read all async, or just actually we can read all, and let's just use a blank method for now because we kind of don't need to do anything. Let's see, and then we're gonna we'll say var count equals await. So the good news is that read all actually does the count for you. It takes however many values that have gone through, and it counts them up. So whatever we do in here, it doesn't matter. So we're going to say here, okay, oops, that was the wrong command. Run. Okay, same thing, right? Now, so what happened here? Well, that pattern which you had just saw is just done under the hood here for you. There are a number of different methods that are available, and I'll post a link to the documentation in the video. But Open Channel Extensions is basically a way of reducing the overhead and the complexity of doing all this stuff. So let's do something else too, right? Let's say we want to actually output some fancy number. We'll call it result, okay? So I'm going to say, var result equals 0, and we're going to say result equals result. All right, and then what's we got going here? Okay, just because I'm consumed. And then within we're going to start by saying in here, we're going to say that the result is, and we're going to change the maximum now to just be, say, like 1,000. And then we're going to say that result equals result. So we're going to do some math, right? Equals result plus I, okay? Reformat. Oh, come on, just trying to do a nice little reformat there. Cool. And then what do we get? Yeah, okay. So that's kind of what we expected, is doing basically a sum of all numbers up to 1,000, and we result in this guy here, okay? Now, okay, so that's cool. What if we wanted to continue doing math in stages? And what if we wanted to do something asynchronously? Let's say that we had an API that we needed to call for each entry in the thing. Let's say let's say that the source was actually a set of IDs that we needed to call, and we needed to call some sort of API. Well, that's pretty straightforward. We just read all async. And this is an extension that, although is the same name as the read all async async enumerable, it is not the same signature. So we're going to go async, and it takes a lambda. And in this case, we're going to say, okay, cool, we want to read all async. And then what we're going to do to basically, how do we say, what we're going to do to promote we're going to simulate the calling of an API. We're going to say await task.yield. Yeah, that's all. We're just going to say, hey, give it a second, right? And again, we're going to get this to return the same results, okay? And so this is another option as well. You can do a lot of really cool asynchronous stuff. And again, it's working as fast as possible through the scheduler, and very little code we're writing here, right? Like, this is pretty straightforward stuff within this class. Now, what if we want to do more, okay? So what I'm going to do is, let's say, what if I wanted to do something a little bit more magical? And let's say we're going to say transform I, oops. And what we're going to say is that I is going to be result plus I, okay? And so that's what we're doing. So now we're getting into like even more simpler code. And, what we're going to say is at the end of this, as the numbers come through, we're going to say that, let's say the last, we're going to say the last result. So var final equals 0, and then say final equals result. So whatever the last one was, we want to know what that final result is, okay? And run. Nope, okay, well that was not what I expected it to do. We need to go I. There we go, sorry. A little bit different because, again, we started with 0 and we're just adding the results up to that point. It's not the same math. But what I wanted to just show you is that, we're taking and looping through this source. We're taking the I and we're doing something to it. You could even do something like, let's do something a little more interesting. Like let's say every time we get I, we're doubling it. It's like 1,000, or let's say we'll do 128, or let's do 32-bit, for example, right? Starting with the result is going to start with 1, and then the final is going to be whatever that is, right? And so let's see here. Yeah, we don't even need this now, right? Okay, and then the I is going to be, sorry, this is going to be a funny number because it's going to go through for every number in the range. It's going to, give you a funny number, but let's see what we get. It's not going to be what I think it is. So cool, we did some more math. But again, there's a lot of usefulness in here, very much like in the sense of a pipelining or something like LINQ. You could very well, come up with some sort of, process where you say, hey, I want to do join. So let's say like batch is an option. So if you want to batch in 10, if you want to join, then you have this option as well. There's some parameters for single reader, which is, you kind of expect, so it says single reader, or actually we'll just say true. There's a lot of simple options on how you want to set up your pipeline. And one last thing I want to share here is, well, okay, you're going, maybe that's cool. I mean, sort of, right? I mean, you could use async enumerable and streams to do the majority of this stuff, and for the most part, that's a good idea. And I do believe there's already an async link library, so that's a big advantage, right? If you actually were able to go and say, let's say like channel dot reader dot read all async. And then we should get, I don't know where it's going to be. Let's say let's select async. Maybe it'll give us the hint on that. Let's see, is it coming in? Well, actually, what do you know? It looks like it this does not contain select async subject for parameter. Could be, let's just see if we have like E? No, okay. Probably have to import it, and that's kind of what I've been really interested in, is can we import the async enumerable link namespace, which I think it already exists. So you could do a lot of this kind of fun stuff with that as well. But this gives you a lot more flexibility, again, having a nice expressive syntax. And so let's say, for example, one of the things that you could do here that is a little bit more aggressive, and say, okay, I actually want to read all concurrently, is another option. So, you can do this instead. Concurrently expects you to give it a max concurrency. So let's say we'll say 3. And that's going to partition out all the tasks for you. And it works very well. It's basically, it's what you'd expect. It's essentially like the equivalent of parallel.for or for each. And you basically get that same kind of result. But again, this is a pipeline, so you want to put all your stuff in here, and the amount, the total, you're going to get back a count, and that's a total. But whatever you need to do in order to sum up these numbers. Now, the other thing to keep in mind, though, okay, is that by default, as you saw, I wasn't doing any interlocking or any type of synchronization of stuff, when doing all these numbers, and that's because I didn't need to. When I was using something that was not concurrent. And that's because the channels are really just within the calling thread are looping 1 through 1 at a time, and you're never going to have a concurrent, any kind of concurrent collisions. But as soon as you switch to a concurrent method, it actually is running concurrently, and you have to be careful about those kinds of things. So, but if you don't need to worry about concurrency, let's say that each one of these IDs is some sort of process that you have to go through. And again, we can even kind of just demonstrate this here, that we're going to come up with a an exception. Task was canceled. I have to look into what happened there. I must not have something set up right. But yeah, basically, why would it be canceled? Well, here, hold on. Let's do something real quick here. Oh, I actually, because I can't do this here. That's why. Let's see if this will, yeah, okay. The whole point behind that join true, by the way, is that it's a single reader. But as soon as you put concurrent, that's the whole point why you have this as a parameter, is you don't want to have this be a single reader when you're calling concurrently. So that was actually a good reminder and discovery about why that exists. But this did run concurrently in multiple threads, and in three different threads to kind of wrap up. Again, that's not that many. So if we were to do like let's say like a million, I might be able to hear my computer fan kick off for like a second. But oh, what happened here? I didn't hit save. There we go. Yeah. So I mean, it definitely fired off, and that's what you got. So that's the advantage of using this kind of thing. You've got a really clean syntax. Again, you don't even, if you just are trying to do some sort of processing and you don't care, you just want to like run something through a pipe. There it is. It's the whole nine. And again, using this as a source is just as a demo, but you can do whatever you want. Again, it doesn't need, like that. You say channel dot, reader. Same thing. The source is just kind of setting things up and pipelining it in for you. We could go back here and say channel writer and get the same results off of this as well. So probably a little bit long. Let's see here. What are we at? How many minutes? Looks like we're at over half an hour. But the point of this was really to be an instructional video for those who want it. If you really wanted to get exposure to channels and kind of demonstrate the patterns that you could be used to seeing. So yeah, I hope this really helps. If you're doing any kind of asynchronous producer-consumer queues, channels are awesome. Like they're super fast. I mean, about as fast as you're going to get in the async world. Data flow has more options. There's some more complicated things that you can do with data flow in a producer-consumer queue scenario, but it's very uncommon to need to use data flow in it to its full potential. It's much more common to have some sort of pipeline that you're setting up, that you're directing results through the pipeline and doing some sort of transformation, or even further, you might even have something that you say where you do like a pipe operation, async. And that pipe operation is actually an entirely separate channel, and you could do that with, again, multiple, threads. Let's see what we got here. Let's Alexa await, and again we'll await. Task yield just to kind of what's going on here. And what am I missing? Let's see, max concurrency. It says the arguments try specify. Oh, right. And then, in this case, I guess it wants to be, let's see, like, or I need to, in pipe, I need to return I. So that's why. Sorry. So that's another example. So piping is another thing that you can do that basically sets up an entirely separate channel within the pipeline to process through these results as well. And we would get the same, thing here if we ran it. We're not going to get any more totals anymore, but it'll run and it'll complete just fine. So a lot of options here. Channels are great for this kind of thing. It's very kind of much of a linear pipe. You're typically not, you're typically not going to fork the results in multiple places, but you can. There's nothing saying you can't. I've even done things where I've had channels within channels running. So, I'd have like some other channel inside this pipe operation doing something that has to complete per result. That's some, stuff that you can do. But again, very easy to do when you have a nice, clean syntax and a structure, an API to support it. So I'll go ahead and finish this up now. If you have any questions, don't hesitate to ask. I'd love to help on this one. I think this is really a big part of, our future, and when it comes to things running and data being processed. And it can be a little bit hard to understand, but hopefully having these extensions in place will help you to make it feel like it's not that not that crazy, and that everything just works as expected. And you're only awaiting, in this case, one operation instead of like 2, 3, or 4. All right, well, that's it for Christmas Eve. You guys have a great set of holidays, and happy coding.